Winter weather slamming the West Coast this morning with heavy snow and flooding rains.
Coldest temperatures are slowly warming up.
After a massive storm left a trail of destruction right across the city.
Sydney residents had the wettest year in 2022 with record rainfall causing severe havoc. However, when scientists began to investigate the unusual weather, they discovered something totally shocking and that goes against what popular science has been saying for years. The Eastern Pacific Ocean is cooling and not warming. Why is this ocean cooling and why does it go against claims made by some climate researchers? Stay tuned as we dive into NASA's expose of everyone lying about how the Eastern Pacific Ocean is cooling and not warming. Many Australians will remember 2022 for two things: rain and floods. At least 10 locations received more than half a meter of rain in a single day. The wettest location in 2022 was Doon in New South Wales' Northern Rivers region, which received 758 millimeters in one day. That total narrowly missed making the top 10 wettest days on record in Australia, but it was the wettest day anywhere in Australia since the late 1990s. The wettest day was recorded by the Ballender Kerr weather station on Queensland's second highest mountain on February 13, 1999, when it received 1,174.6 millimeters of rain. In some areas, scientists were forced to calculate rainfall totals using partial data after floodwaters destroyed the monitors. The rain gauge in Lismore, which has been repeatedly flooded, was knocked out during the February floods and wasn't repaired for months. The city was on track to fall just short of 2,500 millimeters in 2022, breaking the previous record of 2,194 millimeters set in 1950 and approaching Darwin's wettest year, 1998, which had 2,777 millimeters. The Murray-Darling Basin, which is home to much of Australia's food production, was unusually wet last spring, with an average rainfall total of just over 295 millimeters. This was more than double the previous spring average of around 120 millimeters and easily surpassed the previous record of 251 millimeters set in 2011. Meanwhile, it was like somebody somewhere flipped the switch on the weather because before the rain, there was heat. While it may sound hard to believe, in early 2022, parts of Australia experienced roasting temperatures, matching a previous record for the hottest ever day. Prior to this year, Australia had only reliably recorded 4 readings of 50 degrees Celsius or higher, none since 1998. The BOM added 3 more on January 13th. The temperature reached 50.7 degrees Celsius at Onslow Airport in Western Australia's Pilbara, matching the all-time high set 62 years earlier at Oodnadatta Airport in South Australia. On the same day, Roebourne and Mardi, both in the Pilbara, reached 50.5 degrees Celsius. And yet rainfall totals from January to November indicate that 2022 will be Australia's 9th wettest year on record and the wettest since 2011. However, it was the concentration of rain, especially in saturated catchments, that caused havoc for thousands of people in 2022. Floodwaters can take months to make their way downstream in flat inland regions such as Echuca, Victoria, which is less than 100 meters above sea level and more than 1,500 kilometers from the Murray River mouth. These waters reached SA by late December, causing widespread flooding. Only the severe flooding in southeast Queensland, including Brisbane and northern New South Wales in late February, has prompted the BOM to issue a special climate statement. Complicating the issue is the extremely unusual appearance of La Niña for the 3rd year in a row in Australia. Actually, the whole Earth was in the grip of La Niña in December 2022. The current La Niña began in 2020 and returned for a 3rd consecutive Northern Hemisphere winter, resulting in a rare triple-dip event. Other triple-dip La Niñas recorded since 1950 occurred from 1998 to 2001, 1973 to 1976, and 1954 to 1956. Maps depict La Niña in the Central and Eastern Pacific Oceans as areas of cooler-than-average water. Surface waters were roughly 1 degree Celsius or 1.8 degrees Fahrenheit cooler than usual from the South American coast to the international dateline. La Niña events like El Niño have a global impact on weather, which is why when the Pacific sneezes, the entire world catches a cold. The greatest effects of these natural phenomena are felt on either side of the Pacific Ocean. For instance, in La Niña years, floods in northern Australia, Indonesia, and Southeast Asia are common, as is drought in the American Southwest. In fact, the current La Niña has been linked to a number of natural disasters, including drought and food security issues in the Horn of Africa, flooding in Australia, and drought in the United States Southwest. As a part of the El Niño Southern Oscillation cycle, La Niña occurs when energized easterly trade winds intensify the upwelling of cooler water from the depths of the eastern tropical Pacific, resulting in a large-scale cooling of the eastern and central Pacific Ocean surface near the equator. These stronger-than-normal trade winds also push warm equatorial surface waters westward towards Asia and Australia. The cooling of the ocean surface layers caused by La Niña has an effect on the atmosphere by changing the moisture content across the Pacific. It changes global atmospheric circulation and can cause shifts in the path of mid-latitude jet streams, intensifying rainfall in some areas while causing drought in others. During La Niña, rainfall over Indonesia and Australia can increase dramatically in the western Pacific. Clouds and rainfall become more sporadic over the central and eastern Pacific, resulting in dry conditions in southern Brazil, Argentina, and other parts of South America, and wetter conditions over Central America. In North America, cooler and stormier weather is common in the Pacific Northwest, while weather becomes warmer and drier in the southern United States and northern Mexico. There are, however, two other phenomena that complicated La Niña last year, and these are where scientists have focused their research. They are known as the Indian Ocean Dipole and Southern Annular Mode. Basically, these two cyclical events can determine whether you have a good year or not. It is while researching these two events that scientists from the University of Washington made their shocking discovery that challenges claims about climate change. The Indian Ocean Dipole, or IOD, is like the Walker-Sells Indian Ocean Basin Branch, which is associated with the El Niño Southern Oscillation. The IOD is defined by the Dipole Mode Index, DMI, which is a measure of the anomalous sea surface temperature, SST, and the gradient between the western and southeastern equatorial Indian Oceans. Temperature differences between the western and eastern Indian Oceans drive convection and alter the Walker-Sells circulation. The Indian Ocean Dipole generally moves in sync with the phase of the El Niño Southern Oscillation, but there are times when it does not, and it can really shine during a neutral ENSO, such as the strong positive event in 2019. Another distinction is that ENSO typically peaks in the winter in the Northern Hemisphere, whereas the IOD can peak at any time of year. The IOD's effects are felt not only in the tropics, but can also affect weather patterns across much of the mid-latitudes. The Indian Ocean Dipole, like El Niño and La Niña, influences the preferred regions of ascending and descending air in the Indian tropical ocean. The IOD phase helps to determine important aspects of local and global climates. And there is the negative Indian Ocean Dipole. This negative phase of the IOD is driven by cooler than normal SSTs off the coast of Africa and warmer than normal SSTs to the west of Indonesia. The normal circulation is aided by this configuration of surface sea temperatures. The stronger circulation results in more consistent westerly winds over the ocean, more convection over Indonesia, and frequent drought conditions for the Horn of Africa. Warmer than normal temperatures are more likely in the lower 48 states of the US during the negative phase of the IOD, particularly over the Midwest. Warm anomalies are more likely and widespread during a strongly negative IOD event. While this pattern is most consistent with a negative ENSO event, it is worth noting that during a negative phase IOD event, much of the central US experiences the opposite anomaly seen during La Niña. During a negative phase IOD in winter, much of the south and west are likely to be wetter than usual, with the Midwest more likely to have drier weather. During the positive phase of the IOD over Australia in the winter, Western Australia is usually warmer than normal, while the rest of the country is cooler than normal. Much of Australia experiences dry weather during a positive phase IOD in winter, resulting in drier than normal conditions. Drought risks increase significantly during positive Indian Ocean Dipole events. When the IOD is positive in the summer, much of Australia is warmer than usual, but the interior of the north and east is usually cooler than usual. The second phenomenon is the southern annular mode. It is another climate driver that can affect rainfall and temperature in Australia. The SAM refers to the non-seasonal north-south movement of these strong westerly winds that blow almost continuously in the southern hemisphere's mid to high latitudes. This band of westerly winds is also linked to storms and cold fronts that move from west to east, bringing rain to southern Australia. The SAM is divided into three phases: neutral, positive, and negative. Each positive or negative SAM event typically lasts 1 to 2 weeks, though longer periods may occur. The interval between positive and negative events is quite variable, but typically ranges from a week to a few months. The SAM's impact on rainfall varies greatly depending on the season and region. During the winter, the belt of westerly winds is usually close to Australia. Rainfall in the southern parts of the country is typically caused by cold fronts and troughs that pass over Australia's southern reaches. The belt of westerly winds contracts towards Antarctica during a positive SAM phase. As a result, westerly winds are weaker than usual and pressures are higher over southern Australia, limiting the passage of cold fronts inland. In general, this means that there will be fewer rain events in southern Australia during the winter. However, in eastern Australia, the southward movement of westerly winds results in the more easterly onshore flow. Because this wind has just come from the Tasman and Coral Seas, it usually brings more rain to the east. What about the negative SAM phase? The belt of westerly winds expands and moves closer to the equator and Australia. As a result, westerly winds are stronger than usual, atmospheric pressure is lower, and there are more cold fronts and storm systems over southern Australia. This again usually means that there will be more rain events in southern Australia during the winter. However, in eastern Australia, the northward displacement of westerly winds means less moist onshore flow from the east, resulting in less rainfall. In summer, the usual position of the belt of westerly winds is further south of Australia than in winter. Rainfall from cold fronts and troughs is far less common in the summer, while rain from waters to the east of the country is more common. The belt of westerly winds contracts towards Antarctica during a positive SAM phase. Because the westerly winds and high pressure already south of the continent, the southward movement has no effect on rain events in western Tasmania. The southward movement of the westerly winds in eastern Australia causes more moist onshore flow from the Tasman and Coral Seas to be drawn inland, increasing rainfall in the region. Because the east coast of Australia receives the most rainfall during the summer, this effect is much more widespread in the summer. The belt of westerly winds expands towards the equator and Australia during a negative SAM phase. Shifting westerly winds to the north in summer means less moist onshore flow from the east, which reduces rainfall over eastern Australia. The northward displacement of the westerlies means a stronger than usual westerly flow over Tasmania, increasing rainfall in the west. Now, when the researchers from the University of Washington set out to study the climate, their intention was to offer an explanation for El Niño returning 3 years in a row. However, what they discovered flew in the face of climate change theories about the temperatures of the Earth. According to the study, climate change is favoring La Niñas in the short term. What a terrifying thought. Lead author Robert Wills said, "The Pacific Ocean naturally cycles between El Niño and La Niña conditions, but our work suggests that climate change could currently be weighing the dice toward La Niña. At some point, we expect anthropogenic or human-caused influences to reverse these trends and give El Niño the upper hand." The scientists hoped that forecasting the long-term El Niño or La Niña-like climate trends would help to protect human life and property. Global warming is widely expected to boost El Niños. This is because the cold, deep water rising to the sea surface of South America will collide with warmer air. Evaporation has a cooling effect, so the chillier ocean off South America, which has less evaporation, will warm faster than the warmer ocean off Asia. This reduces the temperature difference across the tropical Pacific and lightens the surface winds blowing toward Indonesia, similar to what happened during El Niño. Climate records from the past confirm that the climate was more El Niño-like during warmer periods. However, while the Earth's atmosphere has warmed in recent decades, the new study reveals an unexpected trend in the tropical ocean. Temperatures at the ocean's surface were measured by ship-based instruments and ocean buoys from 1979 to 2020, according to the authors. The Pacific Ocean off South America, as well as ocean regions further south, has actually cooled down. Meanwhile, the Western Pacific Ocean and the adjacent Eastern Indian Ocean have warmed more than the rest of the world. Neither phenomenon can be explained by the natural cycles that climate models simulate. This implies that some process missing from current models could be to blame. As a result of these changes on either side of the tropical Pacific, the temperature difference between the Eastern and Western Pacific has increased. Surface winds blowing toward Indonesia have strengthened, and people are experiencing La Niña winter conditions. The research looks at temperature patterns at the ocean's surface. 30 years of data is insufficient to investigate the frequency of El Niño and La Niña events. What puzzled the scientists was that the climate models were producing reasonable answers for average warming, but there seemed to be something wrong with the regional variation, the spatial pattern of warming in the tropical oceans. What is the reason for this anomaly? The researchers have no idea why this pattern is occurring. Their current research focuses on tropical climate processes and their possible links to the ocean around Antarctica. Once they figure out what's causing it, they might be able to predict when it will eventually shift to favor El Niño. But if it turns out to be long-term natural cycles, scientists expect it to change in the next 5 to 10 years. But if it is a long-term trend caused by processes that are not well represented in climate models, it will take much longer. Some mechanisms have a switch that'll occur in the next few decades, but others could take a century or more. Meanwhile, flooding in Australia continues to wreak havoc. According to data, the destructive flood that swept through southeast Queensland and northern New South Wales in late February and early March of 2022 cost $4.8 billion in insured damages, making it the third most expensive extreme weather event in Australian history. Only Cyclone Tracy of 1974 and the Sydney hailstorm of 1999 caused more insured losses. And the East Coast flood last year was the most expensive flood in Australian history, according to the Insurance Council of Australia, ICA. Nearly 225,000 insurance claims relating to the event have been filed in both states, a 3.6% increase over the previous month's total. Flooding in New South Wales and Victoria in spring 2022 was forecast to cause up to $5 billion in damage to the East Coast grain harvest, with 10 million tons already directly or indirectly harmed. The agricultural damage caused by the floods in southeast Queensland in February 2022 was estimated to be $254 million. The floods affected 17 local government areas and 2,250 primary producers, with the cost of the floods estimated to be 30% of the total production value. Repairing critical infrastructure will take time as roads, transportation, and telecommunications networks have been severely impacted. Damage to public infrastructure in southeast Queensland, for example, was estimated to be $492 million, including 1,718 kilometers of state-controlled roads and ferry infrastructure. And Australians should brace for more water, as the latest forecast from the Australian Bureau of Meteorology is for La Niña conditions to persist in the tropical Pacific into summer in the southern hemisphere, which usually increases the chance of above-average rainfall in northern and eastern Australia. Meanwhile, the southern annular mode will likely be neutral to positive, boosted by La Niña and a strong polar vortex over Antarctica. A positive SAM in the summer months increases the chances of above-average rainfall for parts of eastern New South Wales, eastern Victoria, southeastern Queensland, and northeast Tasmania. Scientists say the sea surface temperatures around Australia have remained much warmer than average, and the waters around Australia in the northern tropics and in the Coral Sea have set new October records. They also claim that the waters in the Coral Sea were the warmest in November and spring on record. Warmer waters in Australia, particularly in the tropics, can cause more evaporation, humidity, and rainfall. Meanwhile, in California, La Niña is causing exactly the opposite effect, exacerbating the drought in the state. California has had 3 of its driest years on record, and the drought shows no signs of abating according to officials. The dry spell has strained water resources and caused conflicts over usage, laying the groundwork for catastrophic wildfires. The 2022 water year saw the wettest October on record and the driest January to March period in at least a century. And yet, even these deluges, which caused flooding and debris flow at times, were insufficient to combat the state's dry spell. Drought-affected landscapes benefit more from soft, wetting rains than from surges, and it will take more than a few winter storms to alleviate California's water shortages. And this weather whiplash is likely to become more common as the planet warms thanks to the climate crisis, which will both worsen dry conditions and fuel stronger storms. And when La Niña staged an appearance for the third year in a row, it increased the possibility of less precipitation. Another dry year would mean that water deliveries from state supplies to Southern Californian cities would be limited to what is required for drinking and bathing. Farmers who rely on state and federal supplies would see even less water during another dry year, putting even more strain on groundwater supplies, which are frequently used as a backup to keep crops alive. However, one of the major concerns is the powder that accumulates on mountaintops during the winter months, which serves as a sort of savings account when the state runs out of water. Snow melts slowly trickling into streams, rivers, and reservoirs, supplying 1/3 of California's annual water supply. Drought has also affected the Colorado River, another major source of water for Southern California, threatening its ability to supply farmers and cities throughout the western United States. Snow levels were far below average by the end of the winter last year, and officials are concerned that a third year of dry conditions will further strain resources. State officials expect the trend to continue, predicting a 10% decrease in California's water supply over the next 2 decades. Precipitation was 76% of average for the previous year, and the state's reservoirs are at 69% of their historical levels, according to state officials. The 2022 water year was slightly cooler and wetter than the previous year, but not enough to change the drought trajectory. According to the U.S. Drought Monitor, the majority of California is in severe or extreme drought. The Central Valley, the state's agricultural heartland, where many of the nation's fruits, vegetables, and nuts are grown, has the worst conditions. Let's hear what you think of powerful natural phenomena like La Niña in the comments section below.